was saying on. So, first of all, thank you, learners, for joining today's demo session. And first of all, like taking your some time from your busy schedule early in the morning and join the meeting. This side, Dia Sharma, and I will be there in your assistance for today's Azure Data Engineer demo session, which is led by Expert IT Academy team. Along with we have our guest, all of you here in the session, and our master trainer Srinivas sir, who will be delivering the session today. So welcoming you all in today's demo session. Srinivas sir, I think you can take the command from here and we are good to go to start the class.
No problem. Thank you so much, Jia. And first of all, thanks for joining for today's demo session team. And as Jia mentioned, my name is Srinivas and I have nearly 20 plus years of IT experience. And I come up with a combination of data engineering and some part of data science. And I majorly uh, build data pipelines mm, using the Azure data stack and also some part of Snowflake. And most of my recent projects where I extensively worked as a Azure data architect and also Snowflake architect roles. And coming to today's agenda, let me share my screen. Please let me know you're able to see my screen.
Yes, sir, it's visible.
Okay, so when I talk about data engineering or Azure data engineering, so there are so many tools available in the market, which are like basically designed or invented for implementing data engineering. As you know, most of the data engineering is not a new term, which was happening for a while. And if you see in early 90s, the data engineering was there, but which is people used to manage with databases, which is database engineering. So people used to leverage databases to implement this data engineering, and where they used to centralize the data in the traditional databases and that data being used for managing the applications. So most of the like RDBMS, like Oracle SQL Server, Sybase, PostgreSQL, MySQL, many different databases came into the market, and which helped the enterprise companies to build their their databases, majorly transactional databases, and they used to leverage the data which they centralized for their normal day-to-day application development. So whenever we moved to the early 2000s, so most of the companies started thinking like how to analyze the data. So most of the companies experience some challenges in the analysis part because real-time data will not be stable, so which used to be keep on changing. So the analysis used to be a little bit deviated. So companies started thinking for an alternative solution where data engineering has been slowly emerged into ETL stack. So ETL, which is like extract, transform, and loading, this has been started, and the birth of data warehouse has been also happened in early 2000s, and most of the companies started centralizing their data by extracting data from multiple different sources and then trying to apply some kind of transformations by converting the data into a desired form and slowly loading into the target data warehouse, which is also a database only, but most of this particular process used to happen with structured form, which is like rows and columns, which is basically from the Excel or CSV files and flat files and some part of the data, and other parts used to be in the traditional from the traditional databases. So most of this data engineering, which is ETL, was happening in the early 2000s, and the birth of data warehouse also started in the early 2000s, and the tools which like Informatica, Data Stage, and also like many different tools also emerged and became leaders in the ETL space. And most of the people who knows Informatica and Oracle, they used to be like the top in the market in ETL stack, and any particular other databases, if you want to see, like SQL Server also captures some market with SQL Server ETL data warehouses also. But most of this data is only structured. There was no any semi-structured or unstructured or quasi-structured data where people were managing. And most of the data engineering started with ETL space. But why we need to use this data integration or data engineering? Why can't we directly use the data which is available? So bringing this data combined together into one centralized location is basically what we use as a data engineer will do. It can be ETL or it can be ELT. There are so many different approaches which people are leveraging, and these two are the common approaches where data is being centralized using different data integration tools. Talend is a big data integration tool after Informatica, Pentaho. So there are so many integration tools emerged later. And what is the main objective of this data engineering also? Most of the companies wants to leverage their enterprise level data, and they want to do some further analysis and then want to take better predictions. And also, if you don't have data engineering, you cannot implement the modern data science or data analysis, all this. We need data. Without data, nothing we can do. Plus, data engineering will give a more clarity and understanding of your business, and it can help us to take better decisions than earlier. If I want to compare my sales, why it is going down, I can compare by leveraging the sales data which is available in the enterprise data warehouse. I can compare the last month and current month sales, and I can go and see the sales trend, whether it is increase or decrease also. And all this can happen only if you perform data engineering. And one more important thing when you go and deal with data engineering is maintaining the data quality also. So while data engineering is going to happen, the data quality also we should see how to maintain, how to perform the data cleaning, how to go and see and is there any data quality is not enough, we need to apply some kind of data cleaning methods, like duplicate values will be there, missing values will be there, some part of data standardization is required. For example, if you go to whatever the diagram, this is unorganized data and this is the organized data. So even in this organized data also we need to see, are there any data quality issues? Because the data is not correct, your analysis also will not correct. So garbage in, garbage out. So data quality is very important, and that should give the right decisions in the upcoming future. So coming to any traditional ETL pipeline, if you see, this will go with this ETL stack, and where you see multiple different sources, like where you'll have nowadays even CRM applications, ERP, and then flat files, some part of unstructured data also coming now, coming to earlier. And most of this data in the any traditional data warehouse will first move to the ODS, operational data source, and from there you will try to transfer that into the enterprise level data warehouse, which will be done with the help of the staging area. The staging area is the place where your transformations and everything will happen. And once my data is available in the enterprise level data warehouse, some projects also will divide that into enterprise level data mart, separate data mart, like department wise data mart. And then each department will try to leverage their own data mart, and then they will build their dashboards. So most of the end users will be the dashboard developers for this enterprise level ETL data. So that business intelligence reports like Power BI, Tableau, ClickView, most of these reporting tools require the final golden source. So which will be either it can be the entire data warehouse, or it can be a part of data warehouse, which is called data mart. A data warehouse is a collection of data marts often. So this particular architecture is basically where the traditional ETL usually will follow. But coming to like an example, if you take any healthcare data, the healthcare companies, they get the data or receive the data from multiple different areas. Public records will be there, patient portals, for example, wearable devices for the patients, and electronic health record they will capture. And also pharmacy, they will have clinics data, laboratories data. Most of this data will come from different sources, but at the same time, each source may not be different. For example, we observe here all the patients data may come in the CSV format, and pharmacy data may be using some different application to maintain, so they may send in the XML form, and the labs may store the data in the form of JSON, and the clinical data may be in Excel, and the research data again may be in CSV. But when I want to centralize this all these sources, I need a enterprise level centralized data warehouse which can integrate all this data and then finally push into the healthcare enterprise level data warehouse. But how to integrate this particular data is important. There are so many tools available. Informatica is there, as I mentioned, data stage is there, Pentahood, Talent, many different tools are available, but most of the data generally will be structured form. But if you see any semi-structured like XML, JSON, and nowadays you are receiving other types of data like quasi-structured also. Anybody know what is quasi-structured data by any chance? The quasi-structured data is basically clickstream data, where you see most of the data will be accessible to the company or enterprise level like portals. They will try to capture the data which is in the form of clickstream data. So to this clickstream data should be like usually will help on understanding the customer. The customer analysis is important. So to bring all this data into a particular centralized location, we need to use different tools here. So tools wise, we have different tools here because the data is growing day by day. Compared to 2004 and now, the data is moving towards billions of records and petabytes of data and zettabytes of data. So to capture this data, most of the social media is the reason, and they are generating this data. So to manage this data, we need to see how we can use different modern big data applications, and even I can use these big data tools. These big data tools also, companies also have some challenges to maintain that. The infrastructure side, you have challenges. Even developer and team wise, you can't manage them. So every company will need a dedicated team where they need to hire. They also need a dedicated person who can maintain this enterprise level big data cluster also. But that is not easy to get the people who can maintain and who knows those many frameworks and technologies also, because daily the data is growing. So how to maintain that is very important for every company. And apart from that, this most of the data whatever you see, this is very helpful for companies to understand their business, and also more data, more in like analysis means you will get better profits also and better revenue. And most of the like companies, why they want to centralize their data is they want to use the data for their business growth. Business growth is very important for any company, so they try to build their own enterprise level data warehouse and use the data for their further business revenue growth. Plus also sometimes they want to understand their customers, how to go and understand my customer interest, which products they are liking and which they are not liking. The recommendation engine, if you go to Amazon, you will find recommendation engine. Amazon also will use this kind of recommendation engines to see the customer interest. So further they have to capture our quasi structured information, like how we are behaving in the website and which pages we are visiting, which products you are selecting. So most of this will be usually captured by many companies, and they try to see how to go and process this data, and we need to see how can we go and store this data first, then only we can process. For example, if you go to the data side, the data also having some challenges like gender. If you see, in most of the places, somewhere it is male and somewhere it is M, somewhere it is MA for male. For female also you can see in different form. To standardize this data, we need to convert into a single gender form, like either M or F. This is called data standardization. This is one of the method in the ETL process. Similar to that, age standardization. If you see here, most of the age column values are not same. Some record it is years, some place it is months, and some place it is date of birth. Some place it is years and months. So this data also need to be standardized. So to do that, I need to use some method or some function and which will convert into single age form. So all these are part of ETL, and the same ETL process has been changed to ELT after big data came, because data volume when it is growing, to manage that data we need big data environment, and the big data environment also people slowly change it to like a huge amount of data, and they started centralizing their big data space, because the data is coming from multiple different sources here, like government sectors, medical sectors. Many different sources are generating this data, but how to like collect this data? Most of the data companies are collecting this data, and they are also converting the data into some desired form, and now they are selling the data to the buyers also. Telecom companies, credit card bureaus, and also we can see many different like banks, they buy the customer data and use the data for their customer like analytics and for their revenue growth also. So most of this data has been generated from different sources, and these are causing the big data growth also. Then companies are also started how to maintain this data. So most of the data which you see in the market, like structured, semi-structured, quasi-structured, and unstructured data. So as a data engineer, if you go to any project, nowadays you are receiving all these types, not only structured. If you go and see any data engineering or big data engineering project, either Azure or any kind of data engineering project, you need to deal with all these types of data. I cannot go and simply say, I will deal only structured data. If you receive semi-structured, quasi-structured, unstructured also, you should be able to process. Structured, we know already, like which is rows and columns, because database tables, plot files will have the same form. Semi-structured data, like XML, Avro, ORC, and then JSON, all will be semi-structured. Some companies are even dealing with this semi-structured data. And quasi-structured, which I discussed already, clickstream data, which companies capture to where they capture the customer actions in this quasi-structured textual form. And then finally, unstructured data also we need to process, because everything is a data in the market now. Document is a data, PDF, image, video. Most of this particular type of data is running in the market. If you are dealing with any kind of generative applications, you need to deal with unstructured data only. If you say, I don't know, people are not accepting. As a data engineer, I should know how to process any kind of data. If I receive a database table, I should be able to process. If I am receiving a CSV or Excel file, I should know. JSON file, I should know. Even semi-structured data like Avron ORC, I should know how to process. If I receive any unstructured data like document also, I should know nowadays how to process, because documents basically will be used to extract some important columns. Some of the real estate companies or legal companies, they extract the customer information from the documents. I should know how to extract such important columns, so that those columns will help the company to analyze and then take some decisions. And PDF mining and image tagging also. Some companies even go to tag their customer images and see how to get some information from the image. Even some companies even tag videos to see the suspicious people. So most of this particular data should be processed by most of the data engineers with the different modern tools. And because the data is growing, if Oracle can you go and see 2 terabytes data means every time I need to increase the size. I can't go and only stick with 2 terabytes. Further increase. So this is basically will be very biggest challenge when your data is continuously growing. So we should have a system or tool that can manage this data and also compute. Compute means how to process. So I need the relevant decent infrastructure to process the data. At the same time, the tool should be able to allow me to store huge amount of data. So normal traditional on-premise can do that, but every time I need to increase the size or increase the capacity. So to overcome these challenges only, we got cloud tools. So cloud tools basically, if you go and see, there are so many cloud services in the market because the data growth is, if you see, it is growing every year. You see here, starting from 2016 to now, the data is now moved to 175 zettabytes. But all this data, if you want to manage, you can't manage in the on-premise databases. So we need a separate kind of tools like where cloud came into the market. When I say cloud, we have like AWS, Azure, GCP, and Azure is one of the cloud which is helping the customers to leverage their services and store their data and then manage with decent infrastructure and data engineering services. We also have some other tools like Oracle Cloud is there, Talent Cloud, but all these are like a little bit costlier and where you need to go and buy the license every time and you need to auto scale and you need to scale up and scale down the data storage as well as the compute, everything. So which is biggest challenge for the companies, and every maintenance you have to even pay. To overcome this infrastructure burden, the company started thinking about that the maintenance cost is increasing. You need a initial capital investment. There is a high risk in the data loss. Suddenly, if something goes down, all applications will be down and need a separate limitation to scale and also require extra IT support. And performance also sometimes we need to optimize. So all these are the biggest challenges for the on-premise data services. So like a big data environment also requires a separate team, dedicated team to achieve all this. If you go to cloud, most of the challenges, whatever we experienced in the big data side, we can easily solve them because companies also face challenges, developers also face challenges in the big data side. So maintenance is one of the biggest challenge. Learning is biggest challenge for the developers also. So most of the companies started thinking about this as a burden and they were looking for a solution. That is where the cloud came into the picture. What are the different features the companies are looking for? They are looking for a cost-effective solution, pay-as-you-go, unlimited storage capacity. So there should not be any restriction on the storage, and automatic backup and recovery should be there. Efficiency in the processing and flexibility should be there. When I can use my services from any device, anytime, from any location, and faster deployment and strategic edge. All these are where companies looking nowadays to build their applications. They want to migrate every on-premise to cloud now, lift and shift. So yeah, they are looking for a solution. So every cloud service is providing the access to their resources from anywhere, any device, from any device, and anytime. So Azure also providing the similar kind of service. So if you see here, most of the Azure services, Azure will provide most of the infrastructure services, like your servers, virtual desktop, softwares, everything will be in the cloud, and we will use a decent internet connection, and we access this infrastructure by using any of these devices. So that is where cloud is helping, and Azure also helping with other compared to other cloud services like AWS and GCP. So Azure is basically one of the like a platform. We can say it is a portal where the user can create an account, register an account, and start logging in and use their platform to create their storage servers and then database servers and then Linux servers, all we can create in the Azure environment with a particular service. So the infrastructure team does not require. Server maintenance is not required. Storage does not need to be upgraded. And then security wise also you will see very better security than on-premise. So normally in on-premise, we need high setup cost to launch any application. But in case of cloud, we do not need any high setup cost. Simply go register your account, log in and start using it and pay after you go. So that is how Azure is also reducing the cost. Pay as you go model, no upfront cost. Automatic software updates, high flexibility to upgrade within few clicks. No additional staff required to maintain your data center because everything is in the cloud. And also data can be accessed remotely over the internet using their web portal using any device. So all these are making the customers or enterprise companies to move from on-premise to this cloud. All this will be eliminated and you will reduce the cost also. And coming to like Azure side, we have different cloud services, and coming to Azure side, a web portal which will try to provide a provision to access all your infrastructures in single location and maintain your building also in a single unified environment. So Azure cloud will provide different services like we have like basic services to create database servers and also like Linux servers. So we have like different ways. But coming to like data side, if you see the main Azure data engineering services like ADF is one of the basic service which will be used for data ingestion. And once after your data ingestion is going to happen from on-premise to like Azure cloud, where your data will come and sit in the Azure data lake generation 2, for example, which is one of the service. And here we will try to divide the data which we centralized into this Azure data lake generation 2 is one service which can help to store your data. And normal traditional Azure projects, data engineering project, we will try to go and follow a medallion architecture. Medallion architecture means you will try to divide your data into bronze, silver and gold layers. So this particular every layer is responsible for one particular type of data. Bronze layer will have raw data as it is. So whatever you receive from on-premise as it is, you store in the bronze layer. And once we move to the silver layer, you will try to use the data for processing, and all the processed data we push into the gold layer. To achieve this, we have tools like Databricks. So Databricks with Azure integration can help me to process the data which is available in this data lake generation 2 in the different layers, and finally push the data into the gold layer that will be utilized by the other services like Azure Synapse Analytics, which is a data warehousing service. And then finally, whatever the data available in Synapse Analytics in the data warehousing environment, the reporting tools like Power BI or Tableau or ClickView, any kind of these tools can be connected and can build the dashboard also. Out of all this, we also can experience the security and data governance features which Azure integrated services. Azure key management, and we have like different Azure cloud like security and governance services are there, data masking and secure data sharing. All this I can implement as part of this on top of this Azure data services. But most of the projects in Azure data engineering will use ADF, Azure data like generation 2 and Databricks and Synapse and Power BI. These are the very common data tools. Every tool has its own responsibility and role, and we use that particular role for that particular requirement. We also can see now a single data ingestion and unified ingestion and main platform to maintain. We got a new service also called Fabric, which is very new, which is basically will use a one lake which is called a single unified data lake. We can also use that, but that still required some time to emerge, and still it is emerging now. But most of these services can be used in like a fabric as a one single location, but it is still emerging and not everybody is started using it. Okay, Raj. And coming to like for this particular course, what we are going to learn, we have different topics which we are going to cover. Let me try to even show you. So what we are going to cover as part of this particular training is, just give a minute. So we are going to like cover the data warehouse basics and also SQL basics. And on top of that, we also need to understand about the cloud side Azure fundamentals, and we will try to learn about all this as a foundation. So once after you finish that, we will try to go and try to jump into the like what are the basic data services in Azure, and then we also will learn about the data services and how to maintain like a SQL server in on Azure, and what are the different pricing tiers, and we also will learn about how to go and understand about the different backup and restore methods, and how to scale up and scale down the database capacity, and how we can like configure the like disaster recovery and the geo replication and all this will be covered as part of database in the cloud. And once after you learn that, we'll need to also understand about the Azure storage side, because Azure basically will work on the storage services like Azure like Blob, and we also have Azure Data Lake Generation 2. We are going to learn these two as part of storage services in detail. And these two are very important because as an intermediate storage, we will use them. And once you finish that, we'll jump into the data factory, which is basically a service for data ingestion. And we will try to see how to manage this entire data factory service by creating data factory instance, and how to create linked services, data sets, activities, and then how to understand different integration and time. And we have the particular components in this particular data factory. We will try to learn each and every component with lab and use case. And the data factory service is very important because most of the data engineering projects will use unified data ingestion, where data factory is going to help us. Once you finish this data factory, during this particular module, you also need to understand the data transformations and how to apply, but majorly we use data transformations by leveraging the Databricks. So Databricks is one of the service which is called Azure Databricks. With Databricks and Azure integration, we will try to understand about how to go and analyze the data and transform the data and bring into a form, and finally how we can go and centralize this data into a data warehouse using Azure Synapse Analytics. And Azure Synapse is one of the service for building the data warehouse on top of the Azure environment, and which was earlier Azure Data Warehouse. Now it has been renamed to Synapse Analytics, and we try to understand about how to build this Synapse Analytics service, and what are the different components, and how to go and apply some part of RBAC, and all this we'll try to learn. And apart from that, we also will try to see how Power BI also can be integrated with this particular Synapse, because most of the end user data will be in Synapse Analytics, and how to connect with Power BI, and how to build some dashboards also we will try to see. And apart from this, we also will try to learn some part of consumption side, Azure AI services, how to integrate with this Synapse and build some part of ML and generative AI models, and which will help us to see how to consume the data in Azure with respect to machine learning as well as dashboard side. So that's what which we are going to learn as part of this entire training, and these are all the modules we are going to cover. And this particular training is a use case oriented training which we are going to learn, and we try to see how to leverage each and every component with use case. And at the end of this training, we also will try to learn about 3 to 4 projects with end to end. by integrating with Snowflake, and we integrate with Power BI, and we'll try to see how to build different pipelines and try to see how we can leverage the end-to-end Azure data services to build data pipelines. And any particular queries you have, you can also ask during the class and after the class. And we also will support in the resume preparation, and we provide some interview questions and interview guidance also, that you can get more details from the team. If you have any specific questions, you can ask me now. Prasanna.
Thank you, sir. This is really informative. What is the duration of this course?
This is basically most of this particular training which we covered earlier is 45 days. We are covering in
Okay.
45 days.
Okay. Is the real-time project will
Correct,
be shown?
correct,
Yeah.
correct. At the end, not one project, we'll see 3 to 4
Mhm.
projects.
Okay. Basically, I'm from automation testing background, completely
Okay,
on Python and
okay,
SQL. I know very little about this data engineering, Azure data
no
lakes
problem,
and Databricks, but
no
I
problem.
have good experience in Python and
Okay,
general SQL, MySQL server.
okay, okay, I got it, I got it. Yeah.
So am I need more prerequisites to take this course now?
No, you already have the prerequisites, because even
Hmm.
if you go and see this
Hmm.
particular course, when you go and start learning also, we start with
Hmm.
data warehousing fundamentals and then
Yeah.
SQL and Python. You already have 2 prerequisites, correct? No?
Yes.
Only data warehousing side, you just need to understand about the terminology and how a data warehouse usually will go and maintain, right? You
Yeah.
might have seen like data modeling, dimension modeling, Snowflake schema, star schema. Because as a
Hmm.
data engineer, we should know these basics also.
Okay.
So Python also we use, because Python is very common for most of the trainings, right, nowadays. If you go and see,
Hmm.
want to explore PySpark, Python is the
Hmm.
foundation. If you don't know
Yeah.
Python, yeah, you can't learn PySpark also. So which is you already have
Hmm.
that. And
Yeah.
most of the like data engineering will run through SQL only. If you go to even like PySpark also has Spark SQL. You will go
Hmm.
to like Databricks also have SQL part. If you go to
Yeah.
like the Synapse also you have SQL. So SQL already is a foundation which you already have.
Okay.
So learning data engineering with Azure, with this already foundation you have, will be easy for you, and you can
Hmm.
explore faster and learn faster.
Okay. Apache Spark also covered in this?
PySpark, correct, correct.
PySpark. Yeah.
As part of Databricks, we'll write the data pipelines by using
Sessions.
PySpark only. Yeah, correct.
Yeah. Okay. Okay. That's it, sir. It's 45 days, right? So
Yes,
it
please.
matches my
Yeah, yeah,
timeline.
yeah, yeah. Any
And
other
Srinivas,
question?
sir,
Uh,
Prasanna wants the classes in the morning time zone. And same goes with Raj, sir, also, because like in the morning time, they were not like able to manage to join the classes. So, Prasanna, I guess the same concern you're also having, right? As you mentioned in the chat.
Yes. I live in CST time zone.
okay, so I mean, like you are talking about your morning is not possible.
Yeah, my morning is not possible for me.
Okay,
My morning is possible, but only after 7:30.
okay,
Yeah,
okay, okay,
before that
okay,
it is not possible. Only after 7:30 I can able to manage in the morning also.
okay, okay, okay.
Mm.
How about Raj? Dia?
For him also the same, sir. I mean, he needs the classes in his evening time zone. He's also in the central time zone. So that's the
How
question.
about like the CS our morning 6 a.m. to 7 a.m.?
This also works. I guess Prasanna, for you also it is work. Like for you, it will be like
Uh, 6
6:30.
a.m. to 7 a.m. means it's 5:30, right, for
No,
us?
no, for you it's 6:30 p.m. Eastern time, Central
PM.
time. The same. In the
Okay.
PM.
Any classes? Any classes during morning? My morning 7:30 to 8 or 9 o'clock.
We need to plan this. because
Exactly, because Prasanna, we have like other candidates also, and they are also like on the working professions. So I think your evening time would works better for everybody.
Okay. Yeah. Yeah. Just send me the timing so that I can check on that.
Yeah, sure, definitely. Apart
Only my
from
concern is that I have two kids. They'll come around at 3:30 p.m. in my time. And, from morning, from that time, I will be mostly with them. So, but I can manage somehow. But let me check the timings and I'll confirm you on this.
yeah, sure. We will discuss with some other candidates also, and based on that, we will
Mhm.
confirm and finalize one time and update you shortly on this. Okay.
Yeah, and also, what is the duration of this class? 1 hour or 45 minutes
one as
time?
of now 1 hour, it may go beyond 1 hour 15-30 minutes also based on that.
Okay. Yeah.
Okay.
Yeah, usually
Yeah.
it is for 60 minutes every day, like Monday to Friday, in this between duration.
Okay. Mhm.
Minimum 1 hour. Yeah.
Yeah, minimum one. Okay, sir. Thank you.
Sure.
No problem. Yeah, no
Thank
problem.
you so much, Prasanna, and thank you so much, Srinivasan, for today's session. Thank you for your
No
time.
worries. Yeah, no,
Have a
yeah.
good day, guys.
Thank you for
Bye.
your time. Have a good
No,
day.
no, no.